All right, we're going to be talking about solving or exponential growth and decay and how we can use exponential functions to model data. All right, it says exponential growth and decay models. The mathematical model for exponential growth or decay is given by these functions, and there's other exponential growth and decay functions also. What this tells you is that if what k is, this A is the amount. Let's say we're talking about a population growing. This A would be the final population or the final amount. A sub naught is the initial amount always. E is just E. That's that constant, Euler's constant, 2.71 something. K is the growth rate. Okay, it's the growth rate or decay rate, depending on if it's growing or decaying. But what K describes is how fast whatever is growing will grow, or however fast whatever is decaying will decay. And then T, of course, is time. If it says if K is greater than 0, okay, then we have a growth function. If K is less than 0, then we have a decay function. Okay, and they look, if it's growth, it's increasing, and obviously if it's decay, it's decreasing. Okie dokie. Alright, and it starts at that initial amount as far as on your graph goes. Alright, so it says the graph in figure 4.22 shows the U.S. population in millions for 5 selected years from 1970 through 2010. In 1970, the U.S. population was 203.3 million. By 2010, it had grown to 308.7 million. Find an exponential growth function that models the data for 1970 through 2010. And what they mean by find an exponential growth function is we have to figure out the rate at which this function, in this case, is increasing. Well, they give me the final amount by 2010, when they stopped looking at their data or whatever. The final amount of people was 308.7. The initial amount of people was 203.3 million. E to the I don't know K, that's what I'm looking for. And the time, well, from 1970 to 2010, to figure out how many years that is, we subtract 2010 minus 1970. You get 40 years. So my time is 40. Now I'm trying to solve for K, which means I need to get it out of the air, which means I need to isolate E so that I can do it. So I'm going to divide by 203.3. So 308.7 divided by 203.3. You get 1.51844567 equals E to the 40K. So now, to get it to drop it, I'm going to take the natural log of both sides. And on this side, if I take the natural log of that big old long number, I get 0.41768721009. ln of E cancels, and this side's left with 40x. So to figure out what, or K, sorry. So to figure out what K is, I'm going to divide by 40. And my K is 0.01044218003. Now, normally we just use 2 places. So if I go out 2 places, my K is 0.01. Which means as a rate, it's growing by about 1%. So now that I found K, I can write my function. The final population, and I'm not saying in 2010, I'm saying now I can create a formula that allows me not to just predict what's going to happen in 2010, but I can make a function and then use it to predict the population after 2010. So now I don't know the final amount. I'm creating this formula to figure that out if I vary the other variables. But my initial population stays the same, 203.3 E, but now my K turns into 0.01 T. And that's what they mean by write an exponential function that models the data. This function represents this exponential function. Okay? Now it says for B, by which year will the U.S. population reach 335 million? So they're telling me they want to know when will the final population be 335 million. Well, all I have to do is solve for t. I plugged it in for the final amount, and just like we did before, I've got to isolate before I can ln. So divide by 203.3. 335 divided by 203.3, and I get, I'm going to come over here, 1.64781111117 equals e to the 0.01t. To get it out of the air, I'm going to take the natural log of both sides. And if I take the natural log of that big long answer, I get 0.49944781112. ln base e of e cancels, and that leaves me with 0.01t. And so now, to get t alone, I'm going to divide by 0.01. And I get, divided by 0.01, 49.94478, blah, 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 blah. If I round, didn't tell me how to round, so if I just round the nearest whole number, it would take about 50 years. Okay? Alright, let's look at another one. In 2000, the population of Israel was approximately 6.04 million, and by 2050, it is projected to grow to 10 million. Use the exponential growth model, a equals a sub naught e k to the t, in which t is the number of years after 2000. Find an exponential growth function that models this data. Alright, well, let's see. The final amount, projected final amount, is supposed to be 10 million. So a is 10. Right now, it's approximately 6.04. E to the k, I don't know. And the span of years from 1950 to 2050 is 100 years, right? Yeah, I trust myself. Okay, so this would be times 100. Yeah, so if I figure out what k is, I'm going to divide by 6.04. 10 divided by 6.04, I get 1.655629139 equals e to the 100k. To drop it like it's hot, I'm going to throw a natural log on both sides. So I have ln of that answer, and I get 0.5041811081 equals 100k, because these cancel. So divide by 100, and your k is 0.005041 blah blah blah, so I'm going to say k is 0.005. So my function is going to be a equals the original 6.04 mil e to the 0.005 times t. That would be my generic function for that set of data. And now they want to know what year, that's time, will the population be 9 million. So they're telling me what they want the final amount to be is 9 mil. So to solve this, just like everything else, I've got to isolate before I can throw an ln at it. So divide by 6.04. 9 divided by 6.04, I get 1.49 blah 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 equals e to the 0.005t. So now, to get x out of the air, I'm going to natural log both sides. ln, natural log, and that answer is 0.39882 blah 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 equals, those cancel, 0.005t divided by 0.005, and the time will be about 79.764, about 80 years. Okay? If that trend holds true. Alright, another population. The population of a particular country was 26 million in 81, and in 90 was 31 million. The exponential growth function A equals 26e k to the t describes the population of this country T years after 1981. Use the fact that 9 years after 1981, the population increased by 5 million to find k to 3 places. Okay. So, whatever it was here's the initial amount. Okay, it was 26 million. If you want the final amount and they told you that it increased by 5 million, they're telling you that the final population was 31 million. Equals 26e to the k times 9, because we're talking 9 years later. So isolate, divide by 26. And you get 1.192307692 equals e to the 9k. To drop it like it's hot, we're going to have to ln both sides. If I take the natural log of that answer, I get 0.17589066665 equals 9k. Divide by 9, and k equals 0.01954, blah, 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 blah. If I round it, that's going to be that 5 is going to bump it up to a 0, which is going to bump that up to a 2, and it's going to be 2. Oh, no, I'm sorry. It's k. That's my growth rate. I'm going to turn it into percent. Okay. 0.0195 is my k. Alright, and that's what they didn't ask me to use to write the equation. They just said find basically the rate at which this thing is growing by. Alright, you try this one, hit pause, come back when you're ready, and hopefully you got 4. The population of a particular country was 22 million in 82. In 92 it was 30 million. The exponential growth function, a equals 22, see that initial amount, e to the kt, describes the population of this country T years after 1982. Use the fact that 10 years after 1982, the population increased by 8 million to find k to 3 decimal places. So if it was 22, it increased by 8 million, that means the final amount was 30. Yeah? Oh wait, t is 10, my bad. 10 or 2, I don't know. Oh, that 10k. Alright, so now we got to isolate. So I'm going to divide by 22. You get 1.3636, blah, 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 equals e to the 10k. Ln both sides. If I take the natural log of that answer, I get 0.310154928 equals 10k, because ln and e cancel. Divide by 12, and by 10, I get 0.031015, blah, blah, blah. And you go out 3 places, 1, 2, 3, the 0 won't do anything to it. Okay? Alright, you try this one, hit pause, come back when you're ready. And hopefully you got 2005. The formula, A equals 134e to the 0.032t, models the population of a particular city in thousands, T years after 1998. When will the population of the city reach 168,000? They're telling me the final population they want to be 168,000. Right now it's 134,000, and the growth rate would be 0.032 times time. So, if I solve this for t, I have to isolate, so divide by 134. 168 divided by 134, I get 1.253731343 equals 0.e to the 0.32t. So to get t out of the air, I'm going to throw a natural log at both sides. And if I take the natural log of that answer, I get 0.22612411795 right? And over here they cancel and I get 0.32t. So now to get t alone, I'm going to divide by 0.32, and time equals 0.032. Oops. 0.226124179 divided by 0.032. There we go. 7.066. So that's approximately 7 years. Well, 1998 plus 7 years is 2005. Alright. Try this one. Hit pause. Come back when you're ready. And hopefully you got 247. It says the size of the coyote population in a national park increases at the rate of 4.8% per year. If the size of the current population is 194, find how many coyotes there should be in 5 years. So they're telling me that the initial population was 194, e to the 0.048, and it's telling me in 5 years how many will there be there? How many of them will there be? Well, the variable's already alone, so we just have to type this in. So I type 194, second divide to get e, caret, parentheses, 0.048 times 5, close the parentheses, and you get 246.622, blah, 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 round to the nearest whole number gives me 247. Alright, so how do you know if an exponential function represents growth or decay? If k is greater than 0, it is growth. If k is less than 0, it is decay. How do you solve exponential growth or decay functions using inverses? We really didn't yet. I don't know why I started that one. I'm going to have to come back and answer that tomorrow. Alright, so we are at homework, which means we are done. So happy homeworking, and I will see you next time.